Hello, this is Mr. Zanolletto. I was going to go ahead and review the notes slightly and then go over a few problems I've already set up and see if we can go ahead and work through those. So the first thing I want to do is go over those notes. Angle of elevation is the angle between the horizontal line and the line of sight. And we're talking about an angle of elevation. First we need to decide in this picture where we're talking from. And in this case, this is where the observer is. Right at that point is the observer. So this is the angle we're talking about. And again, this is the angle of elevation, so if he's standing there, it's rising, or he's elevating his eyes to that. And that's our angle of elevation. And with that angle of elevation, if he's standing there, we always use one of the sides to create it. We use a horizontal line or a level line from his eyes of sight. So this is the horizontal. So when we talk about horizontal, this is the horizontal. And then we have this line, which is his line of sight as he looks up at the lighthouse, at the top of the lighthouse. And this is the line of sight. And then if we look at the angle of depression, the angle of depression is the angle between the line of sight and the horizontal line. And again, we need to realize where the observer is. Well, here we have a nice little picture of him, and that is going to be the point where the observer is. And again, we need a horizontal line from there. So that's the horizontal line. And then he's going to depress his eyes, so that's right here. He's depressing his eyes downward to this line of sight. This is the line of sight. He's looking down at the boat. So here's a line of sight looking downward. Here's a line of sight looking upward. He's standing here, he looks up, angle of elevation. Here he looks down, it's an angle of depression. So, and again, out here, we keep having where here's the point where that horizontal line is coming from. And that's his line, that's his eyesight, and the horizontal line. He looks up for an angle of elevation, looks down for an angle of depression. Over here, we have another horizontal line that they're talking about. And there they look down for depression. Here we have a horizontal line, and they're looking up for angle of elevation. So hopefully that helps. You're always going to have that horizontal line. That's why I keep putting it in red. And that's where most students will go wrong on this type of a problem. Let's go ahead and look at number 2. This is my building or house that's here. And then we have our 12.5 meter ladder and 3 meters from the building. And remember, when this is described, a ladder is leaning against the top of a building. So it's not quite the top, but anyway, towards the top of the building. If the ladder is 12.5 meters long and 3 meters from the base, what is the angle of elevation? Well, if you're having an angle of elevation with respect to this ladder, you have to be at the bottom looking up. So here's my observer. And here's my horizontal line. And he's going to look up. He's looking up here. So we have this right triangle, and you're trying to find that angle. So if that's your right angle, remember our first step generally is to label HOA. We have this triangle, we have our H, we have our angle, H, O, and then around to A. Well, we want the angle. The angle is what we're looking for. This is what we're looking for right here. This angle, that's our X. And we have A and we have H. So we want A and H. That's going to be a problem. Cosine of X will equal 3 over 12.5. Now when we're looking for an angle, that's an inverse problem. We're going to take the inverse of this side. Oops. And when we do that, the cosines cancel out. You get x. Inverse cosine of cosine x is x. Inverse cosine of 3 over 12.5. I want to put that in my calculator. Make sure my calculator is in degrees. It is. And I go ahead and I say inverse cosine, second cosine of 3 over 12.5. 3 divided by 12.5. I get 76.11. So 76.11 degrees. Didn't tell you what to round to, so that's by default I round to 2 decimals. 3 decimals in my honors classes, which would have been 76.113. And that's it. That's for number 2. I got it set up, drew the picture, came up with cosine, set up my cosine function, and then took inverse cosine of both to get my angle. Number 4 said a child holds a string to a kite which flying in the air. If the angle of depression from the kite, now here's my string. This picture may not have been real obvious. This is my string. I'll make my string pink. So this is my string, and it's 40 feet. They said it was 40 feet so long. So that's my 40-foot long string, and they mentioned an angle of depression from the kite. If the angle of depression from the kite, now if I'm at the kite, this is my point of reference, and this is going to be my horizontal. That's my horizontal. And then my depression is coming down here 42 degrees. So now I've drawn in that, and I want the height. So now I have my right triangle drawn with an angle of depression given to me, 40 feet hypotenuse. So yeah, let's go ahead and look at that. If this is my angle, this is my hypotenuse, this is my opposite, and this is my adjacent. So I want the hypotenuse and the opposite involved, which is a SO problem. That's the SO problem. So I'm going to go ahead and set up that. I'm going to have sine of 42 degrees equals opposite over hypotenuse, x over 40. This is a simple multiplying problem. X is going to equal 40 times sine of 42 degrees. So I grab my calculator again. I'm going to put that in. I'm going to put 40 times of 42 degrees. And I get 26.77. If I'm rounding to the nearest hundredth. Nearest thousandth would have been 26.765. I'm going to put 77. 26.77. And they were talking in feet, so that's my units, feet. So 26.77 feet high. The kite is 26.77 feet high. Okay, and one last problem I'll do is, these are difficult. These can be really challenging, but Bo and D are watching a hovering helicopter. And I'm an awful drawer, so I just went ahead and drew. This is my helicopter right here. That's the helicopter. And Bo and D are watching with angles of elevation of 20 and 25. So Bo has the 20. Bo is right here. He's at this point. And D is right there. Is at that point. And their angles of elevation are 20. So Bo had a 20-degree elevation here. Remember, this is my horizontal, and here's his line of sight. His line of sight is going to be here. And D's angle of elevation is going to be 25, is going to be there. 25 and 20. Now, how far apart are Bo and D? So we need to come up with how far they are from each other. I have this for Bo. I have a right triangle, 20 degrees, and Y, and 50. While D's is 50 high as well, that opposite side, but here's his angle of elevation is 25. And this is a horizontal, and that's his angle of elevation, and that's the opposite side. So I'm trying to figure out how far this is, and this is X. So we have our hypotenuse, opposite, and adjacent. And here we have our hypotenuse, opposite, and adjacent. And notice, what we want is A for both of them. And we were given the opposite for both of them. So we have O and A, those are going to be tangent problems. So tangent, Bo is tangent of 20 degrees equals opposite over adjacent, TOA. It's always, I always like writing that out. TOA. So opposite over adjacent is 50 over Y. That's going to be a switcheroo problem. And I expect the other one will be the same. D is going to be tangent of 25 degrees is 50 over X. So yes, we switch them both. This will be X equals 50 over tangent of 25. And this is going to be Y equals 50 over the tangent of 20 degrees. So let's go ahead and crank those in our calculator, and then we'll subtract Y from X, X from Y, and then we'll get our answer. I'm going to put this in my calculator, move this over. I'm putting this in as 50 divided by tan of 20, and 50 divided by the tan of 25. And let's write those two down. Y equals 137.37, and D is 107.23. So I'm going to take that 137.37 minus 107.23. And I put that in my calculator. I push enter, and they're 30.14 feet away from each other. So I subtracted minus these. I get 30.14 feet away from each other. That's it. That's how we calculate that. Again, it's just that Y minus that X, and I had to calculate it, and I pulled those triangles out. Since they were overlapping triangles, I thought that would be a little easier to see. Hope that helps. I don't expect too many of those types of questions for my regular geometry classes, but for my honors geometry classes, you should be aware that that is a possible type quiz question. So I hope that all helps. 3 example problems, and we saw 3 of those worked out. Angle of depression, angle of elevation is very simple. Just make sure you keep in mind that whole idea of the horizontal line always has to be included as you create your angle. Thank you.